8-2 is not that bad either. So that's my goal today. 8-1, finish 8-1, 8-2, and then we'll pick it up next week. Okay. This is different from what we've been doing over here with these problems here, where you have one square root, right? We have one square root, and we have one square root that looks like this, like 96x cubed. All right. And to do this type of problem, what you're supposed to do is use the multiplication rule. The multiplication rule says, hey, you got two things that are multiplied together here, right? Underneath one big square root. You could rip that square root apart into two parts. We'll take the square root of the number and the square root of the x cubed, the variable. That's the multiplication rule. Okay, then what you do is you look at this part over here and you say, well, geez, can we break that down? Well, geez, okay, the square root of 96. There's got to be a perfect square that goes into 96. They wouldn't give you a problem that you couldn't break down even further. So the square root of 96. So you've got to go in that table and just look at all those perfect squares. Those perfect squares have square roots that are nice and even. I think the 16 would do the job here. 16 times 6. All right, that's what 96 is. Notice I put that square root underneath both of these. Let's make it a little bit bigger here. All right, and then we take the square root of x cubed, and we can't do the square root of x cubed because what do square roots do? They take half the power. They divide the power by 2, but you can't divide 3 by 2 evenly. So I taught you a little trick where what you're supposed to do is make this x cubed and x squared, go down one exponent, times x, like so. This is all one big application of the multiplication rule over and over and over again. See, what we have here now is we can break this down and break this down. We'll do the square root of 16, square root of 6, okay, right over here. This is the square root of x squared, square root of x. See that we use the multiplication rule. And then what you do is you go through all your 4 square roots and see if you can break them down. Yep. The whole idea behind that perfect square is to get 16, which is square root of 16 is 4. That's nice. Square root of 6 you can't do much with. Write it down like that. Square root of x squared is x. You know that. Square root of x here. Can't do much with that. And the last thing that you're going to do is you're going to put all the stuff with no square roots together in the front. Marry these two guys, multiplication rule, those two guys gives you 6x. And there's your answer for that problem. All right. Now, in number 17, this is the square root of a fraction. That's the difference there. Now, what do we do with the square root of a fraction? A fraction is a division, right? A fraction is a division. So there's a division rule. There's a multiplication rule, there's a division rule, and that's it. There's no addition or subtraction rule. There isn't any of those. So let me close this out. Don't save it. Let's start a new picture, new one of these guys here. Let's go move this on the side here. And they say, well, what do you do here? Well, here's the division rule. Say you have a numerator and a denominator. You have a fraction. You have a division. And what do you think that is? If you have one big square root of a fraction, it's the square root of the top, square root of the bottom. There you go. That's the division rule. So if you have one big square root, you can rip it apart vertically into two different ones. So in this case here, look, square root of 25 over 49. I'm getting lazy. I'm getting sloppy here. Okay, that's horrible. It doesn't look good. First thing I would do, 25, okay, that square root's like one big container, right? Look inside that container, see if you can clean it up. 25 over 49, I can't do much with. Accept it. If you have to accept it, then what you got to do is you got to say, well, let's take the square root of the top, square root of the bottom, and see what we could do with those two. Well, square root of 25 we can do something with, that's 5. Square root of 49 is 7. There you go. There's the answer for that problem. That's the answer for that. That's the division rule. That's what the rest of those questions are all about. It's not even worth entering. That's the right answer. Any problems so far?
Nope.
Okay. So you got the minus here in front, right? The minus in front means nothing. Okay. Just keep the answer is going to be negative. So just concentrate on this part here. 1 over 64. Underneath that square root, can we do anything with 1 over 64? Like pretend it said 2. Pretend it did this. Pretend they gave you this. 2 over 128. Pretend they gave you that as a problem. Well, before you do anything, simplify the fraction. You always have to simplify fractions. So what happens is you get, I guess we can divide top and bottom by 2. You get 1 over 64. That's the original problem. Okay, that's what we started off with over here. So, all right, 1 over 64 we can't do much with. What you got to do is break it up into 2 separate square roots and see what happens. And these happen to be perfect squares. Now, most of these problems are going to be perfect square problems. It's a little bit harder if they're not perfect squares. We'll figure that out, I guess, in a couple of chapters. But this is negative 1 over 8. And there's the answer for that problem there. Let's see. Did anybody else come in? 5 people. Yay. Yay, yay, yay. All right. So negative 1/8. Come on. What's the next one? Next one. Next one. What do you think this answer is? Let's see if I can do a clean. Let's do file new.
I don't know.
Let's see what this is. I'll do a new one. Let's clean this out. Don't save it. Okay. What do you think that answer is? Square root of 4 over x to the 8th. There's not much you can do with 4 over x to the 8th. You can't simplify it, right? What can you do? Rip it up into 2 parts, top and bottom, separate square roots. If I have separate square roots, I get the square root of 4, which is 2. Square root of x to the 8th. I could take half of 8 to give you this. There's your answer for that problem.
That's it.
Okay, that's the answer for that problem right there. What's the next one? Ooh, okay, let's take a look at this one. Negative square root of 5 over 4. The answer is going to be negative. Forget the negative. The negative is just an annoyance. But I can't do anything with this. I can't. 5 over 4. Can't do anything with it, so live with it. All I can do, if you got 1 square root, maybe rip it apart, top and bottom, into separate square roots. And then what do you got? Well, what you got, the square root of 4 is 2. I got that. Minus, can't do anything with square root of 5. That's what the answer is. That's what it is. See? So I've been throwing some of these problems out. Let me see if I'm getting any of these right. Maybe I'm lying to you. Make a fraction. I like to put the negative on top. It don't matter where you put it. Square root of 5 over 2. Check your answer. Yeah, there you go. Still got it. Still got it. What do you think? This has got to be easier than chapter 7.
Yeah, it looks like it. Yeah.
Yeah, of course it is. Of course it is. Now, this is a big mess. So let me take a look at that one. Let me take a look at that one. Let me see what the next ones are. That's the same thing. Okay, now we're going backwards. I'm not sure why they did that. Okay, word problem. Okay, here's what we're going to do. We're going to do a few of these. Let's go backwards here. All right. I think I'm going to do a new canvas here. Don't save that. Let's do a file, new. Okay, nice clean canvas here. Move this over here. Make a big square root. 7x squared y to the 6th over 25. First thing I would do is, can I clean up? Forget the square root. Can I clean this up? Can I do anything with this fraction? Simplify it? Nah. Can't do anything with it. If you can't do anything with it, live with it. That's equal to. Okay, that's equal to square root of 25 on the bottom. You're going to do separate square roots. Square root of the top. Divided by the square root of the bottom. Square root of 25. Let's save my hands here. Square root of 25 is 5. No square root. Don't put that in there. Don't put that in there because that's nice, but you know we can rip this apart horizontally. See this? There you got a bunch of things multiplied together underneath one square root. You got to do the stuff that we learned before. Rip up those to make those 3 separate square roots. Okay, and then what happens is square root of 7 is what it is. Can't do much with this. And the nice thing about this is that these are even exponents. I could take half of 2, which is 1, exponent 1, and this is y cubed, and over 5. There's your answer. Now, I'm going to enter. If I enter, I think the computer will take it. We'll take it the way I wrote it over here. It will take it.
I have a question.
Go ahead.
Is it what you cycled? Is it y power 3?
That's y to the 3.
Y to the 3. Okay.
Yeah.
Thank you.
Because that's half of 6 is 2. Half of 6 is 3. Half of 6 is 3.
Okay.
But if we want to go to the math parties at UMass, they wouldn't accept this as being a good form. You got to put your square roots at the end. Okay, so in other words, make a fraction, keep the 5. 5 is what it is. The whole parts in the front go in the front with no square roots. The stuff with no square roots go in the front with the cube. Get off of there. Let's make this bigger. Okay, and where's the square root of 7 goes at the end? So square root of 7 goes at the end. That's going to make you go into the math parties. Okay, check your answer. Well done. All right, what do you think?
That's cool.
Yeah, this looks the same. This is the same thing. I'll let you do that. That's the same thing as what we had to do, but what I just did, just different numbers. Square root of 12. You know what? Let me just do it. Let me just do it. There's a little gotcha there. Don't save it. Let's do a file, new. There's more work to this problem than the other one. I should have probably did this one. Okay, keep that. Negative square root of 12 x to the 8th y divided by 49. Okay, looks ugly, but you got it over here. 12 and 49, there's not much I can do with, so we got to accept this fraction the way it is. So you're going to take the square root of the bottom, square root of the top. Right now, they're just giving you perfect square roots on the bottom, so that's good. Got 7 on the bottom. I'm going to put the negative up top. I'm going to rip, this is the square root of the top. Will you let me just skip one quick step here? Square root of the top. I'm going to rip that square root into 3 separate square roots. See, what I basically did is I skipped a little bit of a step. I'm going to take the square root of the top. The square root of the top is the multiplication of 3 terms, so why don't we rip those square roots into 3 separate square roots while we got it? Okay. Now what you got to do is see if we can take a look at the 12. 12, square root of 12. Is there a perfect square that goes with the 12? Some people say 6 and 2. That's all well and good, but 6 and 2 is not going to help you with this problem. 6 is not a perfect square. Okay, certainly this is true. But how's that going to help you? The square root of 6 you can't break down. The square root of 2 you can't break down. So you got to make sure you have perfect squares. Square root of 4, square root of 3 is much better. Because that square root of 4 I can break down to be a 2. Square root of like half of 8 I can do. It's x to the 4th. Square root of y, there's not much you can do there. Just accept it. Over 7. And then last is going to be -2, which is good. -2. Square root of 3. I can't do much with that. X to the 4th. Square root of y. Over 7. Don't write that. What they want you to do is take all the whole number stuff, put it on the front. Still have a fraction. All the stuff with no square roots merged together. And the stuff with, these are two separate square roots that I can merge together into one house. 3y over 7. There's your answer. Let's see if that's right. Let's put that in there. -2x to the 4th power. 4th power. Bring it down. Square root of 3y over 7. Check your answer. Yep, there you go. That's it. So that's good. That's good. This is the stuff we did before. I know they went backwards here. I don't know why they went backwards. This should have been the very front of the homework. Okay, now what do we do here? They go, oh, a bunch of words, a lot of words, and I'm not sure. I think this might actually be a real equation that the state police use to determine how fast a car goes when in an accident. You know, basically you measure the skid mark that the car makes. The longer the skid mark, the faster the car must have went. But we'll accept this as gospel. Okay, so I'm just going to copy this. So if you have this guy here, under certain conditions, this expression can be used to approximate the speed of the car in miles per hour. If you measure a skid mark that's L feet. Now, what you're going to do to find the speed is you're going to copy this equation. 5L, okay, that's the equation. What we're going to do is take this 180 feet and substitute it in for L. So that's 2 square root of 5. Now, this is multiplication. This is not 5, and you substitute 180. That's not 5180. You're going to multiply by 180, okay, and that's it. That's all this problem is. So what you're going to do is say 2, 5 times 180. What's that equal to? Square root of 900. 900. Square root of 900. And if you go in your calculator, square root of 900 looks like it might be 30. 2 times 30. Uh-oh. Okay, what did I just do?
The cross. The cross. Yeah.
Less, okay. 30. And so this is equal to 60. Yay, 60 miles an hour. Must be right. Whole number. They probably won't give you a problem that's not a whole number. So what do you think of this progression? Any problems here?
No.
Good. 60 miles an hour, time of the accident. Boom. Okay, there you go. Oh boy. So this looks harder than it is. Don't read into it any more than it is. And the last thing is a soccer field. Okay, this might take a little bit of work, so let me clean this out here. Get rid of this. Don't save it. File, new. Okay, let's move this over here. Move this toolbox over here. So we have a soccer field, a rectangle. Here's your rectangle. They measured the length of the soccer field to be 60 yards and 50 yards wide. I'm not sure if these are real dimensions, but it's all right. And for whatever reason, they want you to determine the diagonal. Okay, so this is B in this picture. This is B, and this is A, and this is the diagonal C. So what do you got to do? So here's what they say. Give the exact answer. The exact answer is always with a square root in it, and then the approximation to 3 decimal places. All right, we'll figure this out. How are you supposed to do? You remember that Pythagorean theorem? Sure you do.
No.
A squared plus B squared. These are the legs of the right angle. Here's your right angle. So A squared plus B squared equals C squared. That's your starting point. You got to have a starting point. And so what you're going to do is you're going to substitute the legs. These are the legs, 60 squared plus 50 squared equals C squared. All right, so what do we got? 60 squared is what? 36. Just, oh, I get a lot of people make the 60 squared, they put down 120. Don't do that, please. Okay, this is not multiplication. This is 60 times 60, which is 3,600, plus 50 times 50 is 2,500 equals C squared. All right, so we're not doing any fancy math here. We got to add those two numbers up. So let's add those two numbers up. 0, 0, 6 and 5 is 11, and then I'm going to make this 6,100 equals C squared. Okay, so C squared is equal to 6,100, but C squared is nice, but it's not C. What's the opposite operation of a square? What are you supposed to do to get rid of a square? What would I do here to get rid of that square? What's the opposite operation of a square? Well, we've been doing it all. Square root, right? The square root. Take the square root of that. See, if I took the square root of that, the square goes away, right? Whatever you do on one side, you do on the other. This cancels, gives you C, and this is the square root of 6,100. And that's all well and good. Let's try that. That's the exact answer is square root of 6,100. That's the exact answer, but it won't be right because it's not simplified. So let's feel a little pain. Oh, geez, there you go. What they're basically saying there is there's probably a perfect square that goes into that. If it ends in 2 zeros, that means 100. That's the same thing as saying 61 times, let's do a multiplication, 100. All right. Rip that into 2 separate square roots. Square root of 61. Get out of that square root. Make it times. Again, here's a times. Square root of 100. And that's equal to square root of 61. Get out of there. Times square root of 100 is 10. Okay. But you're not going to write it that way because you want to put the whole part's got to be in front of the square root. The square root's got to be in the back. So the way you're going to write that is going to be 10 square root of 61. And there's your right answer. That's the correct answer right there. Okay. There's your correct answer. Oh, geez. 10 square root of 61. Check your answer. Yay, fantastic. Fantastic. What's the length? Okay, yeah, when the square roots are nice, but you can't go to Home Depot and say, give me a board that's square root of 5 length. They don't know what the hell you're talking about. They want real numbers, decimals and stuff. So what they want you to do is take this, or actually take this original number. It's probably easier to take the original number, square root of 6,100. Go inside your calculator. I've got my calculator going here. Where's my calculator? I'm going to punch in. What? I got it right here. Where's my calculator? Oh, there's my calculator. Okay. I'm going to punch in 6100 square root with the 2. There's the answer. Okay, they want nearest thousandths, 3 decimal places. 1024. Stop and forget about all this stuff. That's the 3 decimal place right over here. 4 is a small number. If it was a big number, you'd make this 3. But if it's a small number, get rid of all those digits. I'm going to say that the answer is going to be 78.102. Okay, then go in there. 78.102. If this was like a 6, I would say 103, because you have to estimate, round it. Okay, check that answer. There you go. So what do you think of square roots, huh? All this stuff. Still got to be better than Chapter 7. Chapter 7. So what do you got to do right now? Here's what you're going to do. Where's my... No, I don't want that one. This is the one I want. We're going to finish 8.2. There's not much there. There really isn't much in 8.2. Then after 8.1, 8.2, you're going to do quiz 8A, and you're going to enjoy the weekend. Okay?
Okay.
You should be able to bang this out, bang these things out pretty good. So don't forget the quizzes. Don't forget the quizzes. So let's come back. Let's go back here. Oh, I needed to go back. I needed to do this. Let's preview 8.